By the time they named the company, the man who made it possible was already trying to disappear. They built weapons to destroy concrete. Then a nation that never fought turned those weapons into an empire. By 1985, every major American construction site, from the Embarcadero in San Francisco to the tunnels beneath Manhattan, was running on tools designed in a landlocked country smaller than Maryland. A country with no coal, no iron ore, no manufacturing tradition older than 100 years. Switzerland didn't just compete with American heavy industry, it made American heavy industry irrelevant. And it started in a converted brewery, in a village you've never heard of, with a man who arrived carrying drawings he refused to explain. The Hilti brothers, Martin and Eugen, didn't come from engineering royalty. They came from a mechanic shop in Schaan, a village in Liechtenstein so small you could walk its entire perimeter in 11 minutes. And the thing they built in 1941 wasn't supposed to change anything. It was supposed to survive. When the first Hilti pneumatic hammer arrived at a Cleveland demolition yard in 1952, the foreman placed it on a workbench, examined the casing, then locked it in his office. He didn't allow his crew to use it. Not because it didn't work, because it worked in a way that violated what he understood about physics and metallurgy. And there's something else. A page on the company's internal archive, not the public-facing website, the other one, that ends mid-sentence, dated March 14th, 1989. Every employee hired before 1995 knows exactly what it refers to, but nobody uses the word out loud. We'll get there. First, you need to understand what a jackhammer actually does to the human body. The tool doesn't rotate. It doesn't grind. It delivers kinetic energy in discrete packets, between 1,200 and 2,800 percussive strikes per minute. Each strike generates a shock wave that travels through the handles, into the palms, up through the forearm bones, through the elbow joints, into the shoulder girdle, and disperses across the skeletal frame. After 6 hours of operation, your hands stop closing correctly. After 6 months, you lose fine motor control. After 3 years, the tissue around your joints begins to calcify in patterns doctors called stonecutter syndrome, before they renamed it hand-arm vibration syndrome and pretended it was a new discovery. The Americans knew all of this, and they built their hammers anyway. Heavier, louder, cheaper. Hilti did the opposite. Schaan, Liechtenstein, 1941. Not Switzerland, Liechtenstein, the microstate wedged between Switzerland and Austria. A principality with 11,000 people and no standing army. Martin Hilti is 33. His younger brother Eugen is 28. They've just opened a mechanical engineering shop in a converted brewery, and every country around them is either fighting or preparing to be invaded. The brothers have no access to steel imports. What they do have is proximity to Swiss precision manufacturing culture and a single contract: components for agricultural equipment. Seed drills, harvester teeth, nothing revolutionary. But Martin, who never finished his engineering degree, starts noticing something about the pneumatic drills the road crews use in the Alpine passes. They fail constantly. Seals crack in the cold. Housings warp. Chisels snap because the tempering is inconsistent. And Martin starts asking a question a farm equipment maker has no business asking. Why does nobody build these right? He doesn't know the answer. Not yet. But he's about to meet the one man in Central Europe who does. And that man is trying to disappear. His name was Eduard Weiss, Swiss national, former engineer at Bosch's pneumatic division in Stuttgart. In 1942, he arrives in Liechtenstein with no references, no paperwork, and a metal case containing technical drawings he will not explain. Weiss doesn't ask for a job, he asks for asylum. Martin Hilti doesn't understand why a pneumatic engineer would need asylum. He hires him anyway. For 6 months, Weiss says almost nothing. He works on the lathe, he tempers chisels, He listens, and this detail matters. He listens to the sound the metal makes when it cools. Then one morning in January 1943, he sets a prototype on Martin's desk. A handheld pneumatic hammer, 4 kilograms, half the weight of anything comparable on the market. The casing was aluminum alloy, not steel. Aluminum, which everyone in the industry knew was too soft for percussion tools. Except Weiss had done something to the interior sleeve. A surface hardening treatment that wouldn't become publicly understood until the mid-1950s. He wouldn't write it down. He just said, "Test it." They tested it on a limestone block in the back of the shop. The hammer ran for 11 hours without overheating. The chisel didn't snap. And Eugen, who operated it the entire shift, could still grip a pencil when it was over. That had never happened before with any tool in that class. Because Weiss hadn't invented the process at Bosch. He'd taken it from somewhere else. The original research came from a military laboratory outside Berlin. Percussion fuses for artillery shells. The goal was an impact trigger that could withstand 8,000 Gs of acceleration without deforming. Weiss had adapted that metallurgical process for tool manufacturing and then fled before anyone could ask why a civilian engineer had access to Wehrmacht research files. Martin Hilti never asked where the drawings came from. He just started production. By 1946, Hilti wasn't making farm equipment anymore. The sound in the Schahn factory changed. Pneumatic hisses, the bright crack of hardened steel on stone, the low hum of the first rotary compressor, installed using Swiss bank financing that Eugen arranged and never fully explained. They were selling reconstruction tools to French, Belgian, and Dutch crews, anyone rebuilding roads and rail lines the war had destroyed. Then, 1949, a Hilti hammer arrives in Boston, brought back by a U.S. Army Corps of Engineers officer who'd seen it used in a Bavarian tunnel project. He hands it to a site manager at a demolition company called Wentworth & Sons. The manager, Carl Decker, had been using American pneumatic tools since 1938. Ingersoll Rand, Chicago Pneumatic, companies with foundries the size of city blocks. He thought the Hilti was a toy. Then he ran it for 3 days straight, and it didn't lose compression. That wasn't supposed to be possible. American hammers used leather gasket seals. They degraded in heat, swelled in humidity, cracked in cold. Replacement was expected every 40 to 60 operating hours. Hilti used a synthetic polymer compound sourced from a Zurich supplier, a material that wouldn't appear in American tools until 1957. The result? 1/5 the maintenance interval. So why didn't American companies simply copy the seals? Because Hilti didn't patent them in any accessible way. The company filed patents under subsidiary names, shell entities, and in some cases under Weiss's name, in jurisdictions where records were digitized and weren't reachable by foreign legal teams. It would take competitors years just to locate the filings. And by then, Hilti had already moved on. The pneumatic tool industry in the United States wasn't a free market. It was a coordinated oligopoly. 4 companies, Ingersoll Rand, Chicago Pneumatic, Thor, and Cleveland Pneumatic. They didn't compete on price. They allocated contracts, shared supplier networks, and operated under an unwritten agreement. No disruptive innovation. Improvements were iterative, marginal, controlled. Then in 1952, Hilti opened a sales office in New York. Not a warehouse, an office with engineers. They offered something American companies had never considered: on-site tool customization. If a contractor needed a hammer tuned for a specific concrete density, Hilti would adjust the piston weight and spring tension on-site. Same day, no special order, no upcharge. The American companies tried to buy Hilti. The offer came through a Zurich law firm. The bidder was anonymous. The price was enough to retire both brothers and every employee in Schahn for life. Martin Hilti declined in a single sentence: "We don't sell what we don't own." It wasn't arrogance, it was architecture. Hilti was structured as a family foundation, a Stiftung, under Liechtenstein law. The brothers weren't shareholders. The 1948 charter made acquisition legally impossible. Ownership could never transfer to a non-family entity, and profits above a certain threshold had to be reinvested in research or employee welfare. A poison pill written into the corporate DNA before there was anything worth protecting. In 1954, Chicago Pneumatic released a new hammer. Lighter casing, polymer seals, modular chisel system. It looked exactly like a Hilti TE5, same footprint, same weight, even the same red and gray color scheme. Hilti's legal team prepared a patent lawsuit, then pulled it, because the Chicago Pneumatic hammer failed in field testing, catastrophically. The casing metal was the wrong alloy, the seals were the wrong polymer family, similar chemistry, wrong durometer. The chisel temper was too brittle for sustained percussion loads. It wasn't a copy. It was a cargo-cult version of a copy, the shape without the size. When it started cracking housings on job sites across Illinois, the reputation damage didn't touch Hilti. It destroyed Chicago Pneumatic's credibility in the commercial segment. Hilti never commented publicly. They just kept iterating. By 1960, they'd solved something no one else had managed. A rotary hammer that didn't destroy its own gearbox. A rotary hammer combines percussion with rotation simultaneously. Faster, more versatile, better for reinforced concrete. And it generates internal torque that tears apart the coupling between motor and hammer mechanism. American versions lasted around 200 operating hours before gear failure. Hilti's lasted 2,000. They used a planetary gear system borrowed conceptually from Swiss watchmaking. Precision bearings that distributed load across multiple contact points instead of concentrating stress at a single mesh. Over-engineered by any reasonable standard, expensive to produce, and it made the tool nearly indestructible. Contractors started talking about Hilti hammers the way pilots talked about certain aircraft. You could abuse it, and it wouldn't punish you. Somewhere between 1965 and 1968, Hilti stopped being the European option and became the default. The red cases appeared on every major site. The Sears Tower, the BART tunnels, the World Trade Center foundations, not because of marketing, because American tool companies got lazy. The post-war boom was ending. Margins were shrinking. Ingersoll Rand and Chicago Pneumatic started cutting costs. Thinner steel, offshore seals, longer gaps between model updates. They assumed brand loyalty would hold. It didn't. The major contractors, Turner, Bechtel, Kiewit, started specifying Hilti in their equipment contracts. Not Hilti or equivalent, just Hilti. And once that happened, the economics cascaded downward through every tier of the industry. You bought Hilti, or you lost the work. And that's when the accident started. Nothing traceable. Nothing Hilti could prove. But between 1971 and 1974, 6 reported incidents of Hilti tools failing in ways that matched no known failure pattern. A piston head shattering in Detroit. A trigger assembly discharging a chisel through a form wall in Sacramento. A gearbox filling with metal shavings after 9 hours in Newark. Hilti engineers retrieved the tools and disassembled them. They found components that weren't Hilti parts. The Detroit piston was the wrong alloy. Close, but measurably different under spectrometry. The Sacramento spring didn't match any catalog specification. The Newark gearbox contained filings consistent with deliberate contamination rather than normal wear. Someone was replacing components in the field with near-perfect counterfeits designed to fail. Hilti never made a public statement, but within 60 days, they changed everything. Every individual internal component received a laser-etched serial number tied to its production batch. And they introduced metallurgical tagging, trace elements embedded in the alloy during casting, identifiable under spectrometry, tied to a specific production date and line. You couldn't fake a Hilti part anymore without a laboratory and a foundry working together. The reason American companies couldn't copy Hilti was never a single patent or a single material. It was a system. The Hiltis understood from the beginning that a tool wasn't a product, it was a platform. Every part engineered in relation to every other part. The seal material chosen relative to the piston alloy, the piston weight relative to the gear ratio relative to the expected operating environment, and the whole system designed for repair and longevity, not for replacement cycles. American companies built tools to sell tools. Hilti built tools to sell trust. And trust, it turned out, was harder to replicate than any polymer compound. By the mid-1990s, Hilti did something with no precedent in the tool industry. They stopped selling tools. They started leasing them. Fleet management. A contractor didn't purchase a Hilti hammer outright. They subscribed to a service. Hilti delivered the equipment, maintained it on a scheduled basis, replaced it at end of service life, and tracked usage data to refine the next generation. Software logic applied to heavy hardware, and it locked customers in more completely than ownership ever could, because you can't switch platforms mid-project when the platform is also your maintenance contract. By 2005, fleet management generated more revenue than direct sales. Contractors paid more in aggregate, but eliminated downtime costs, repair budgets, and capital expenditure planning. The usage data fed directly back into engineering. The tools got measurably better because the business model created a feedback loop no pure sales competitor could replicate. Now, March 14th, 1989. A shipment of Hilti TE76 rotary hammers arrives at a construction site in Lyon, France. The contractor opens the first case. Right serial number, right weight, right color. But when he pulls the trigger, the motor runs backward. The chuck rotates counterclockwise, which is mechanically impossible. The gearbox is unidirectional by design. He opens another case. Same problem. 12 tools, all rotating the wrong direction. An engineer arrives from Hilti's Paris office, disassembles the first tool on a folding table in a site trailer, and finds a motor assembly that isn't in any parts catalog. The wiring reversed, the rotor machined in mirror image to specification. A Hilti tool built with Hilti-grade components, assembled deliberately wrong. Hilti traced the serial numbers. The batch logs showed those tools had been destroyed 6 months earlier. A housing mold defect, entire run officially scrapped. They were taken from the factory floor by someone with access to both the production line and the serialization database. 3 senior employees left Hilti within 90 days. No severance, no reference letters, no explanation. The most credible reconstruction, someone inside Hilti had attempted to establish a counterfeit operation. Not a competitor, an insider. The plan was to distribute near-perfect clones through gray market channels in North Africa and the Middle East, markets where Hilti had brand recognition but limited direct service presence. It almost worked. And if counterfeits carrying valid serial numbers had reached job sites and failed, it would have destroyed the one thing the entire company was built on: the certainty that a Hilti tool was a Hilti tool. That's why the incident doesn't exist in any public record. Not because of the theft, because of what the theft was aimed at. Today, Hilti employs over 30,000 people. Revenue exceeds $6 billion annually. Headquarters still in Shan, still a family foundation, still immune to acquisition. Martin died in 1997, Eugen in 2008. The structure they built endures. Eduard Weiss left Hilti in 1957. No public reason. He moved to a village outside Lausanne, worked as a machinist, and died in 1979. 4 lines in a local obituary. No interviews, no papers published. His drawings are still in the Shan facility. Climate-controlled archive, non-digitized, biometric clearance required. And every few years, Hilti releases something that sits just slightly ahead of the publicly known material science curve. a vibration dampening system that shouldn't be achievable with current polymer technology. A drill bit coating no independent lab has successfully reverse engineered. Whether that's the Weiss legacy or 80 years of compounded engineering knowledge, the company won't say. Walk onto a major construction site today. Dubai, Toronto, Sydney, anywhere. Listen, you'll hear it. That flat, clean crack of hardened steel on concrete. Not loud, not dramatic, just relentless. The same sound it made on a limestone block in the back of a brewery in 1943. There's a tool in the Hilti archive that has never been photographed, never displayed, never mentioned in any company history. The first hammer Weiss and Martin built together. Every few years, an engineer takes it out, connects it to a compressor, and runs it on a test block. Just to confirm it still works. Just to hear what it sounds like when you build something correctly the first time. And the Weiss drawings, according to one engineer who saw them in the early 1990s, contain a final section near the back. Handwritten notes, in German. Schematics for a tool that, as of the time he saw them, didn't exist. Something about energy transfer mechanics that the materials available at the time couldn't support. He wouldn't say more than that. Hilti won't confirm the page exists, but somebody, at some point, designed something they haven't built yet. And the only question worth asking is whether they're waiting for the right moment, or the right material, or whether they already built it, and they're simply not ready to let anyone know.